Okay, so before I get started with the video, I want to start out with a corny joke. Did you know that 5 out of 4 people struggle with fractions? I'll let you think about that one. Okay, this is finding slope and y-intercept 2-5a. I should probably have an A in there. The I can statement. I can find the slope and y-intercept of a linear function represented in multiple ways. So we're going to look at linear functions that look in all different forms and find the slope and y-intercepts. We're going to define those things and then just do 3 quick examples. A lot of this is review. There are a few new components. Okay, so first we want to look at what slope means. Slope is rise over run. So in this particular example, we have the point -4, -2, and we have the point 1, 6. Remember, we always list the x value first, then the y value. This is the x-axis, this is the y-axis. So we're always listing that horizontal value before the vertical value. The y-intercept is simply where the line intercepts the y-axis. So this green line appears to intercept the y-axis right around 0,4, right around the point 0,4. And something to keep in mind, that slope, point slope form, y equals mx plus b, b represents this y-intercept, and m represents the slope. Now, if slope is rise over run, then we can just simply count what's the rise, or the vertical difference between these 2 points. Well, let's go. 1, 2, 3, 4, 5, 6, 7, 8. Looks like we got to go 8 up here. And let's see how many we have to go over. 1, 2, 3, 4, 5. So the run's 5. Okay, so our slope is 8/5, and our y-intercept is close to 0,4. It looks like it's just above 4, so it might be like 0 and 4.2 or something like that. But that's all this means. The slope is rise over run, and the y-intercept is where this green line is going to intercept that y-axis. Now we're going to look at how to find these things for a variety of functions. Okay, this first function is the easiest because I gave it to you in graph form. So it's super simple. Pick 2 points on the line. It doesn't matter which 2 points. The slope is going to be the same because it's a line. And figure out what the rise is. We go up 1. Figure out what the run is. We go over 1. So the rise was 1 and the run was 1. So our slope must be 1. So that's m, which is our slope. These are all meaning the same thing here. But the y-intercept, it looks like this red line intersects the y-axis right here at the origin, or 0, 0. So that's pretty simple. The slope is 1, and the y-intercept is 0, 0. And I'll abbreviate that. Y-intercept. So when you have a graph line, that's the easiest way to answer these questions, in my opinion, because you just look at the line and tell. Oh, one last thing. I know this is a positive slope because it's sloping up. If it was sloping down, we would use the same method, rise over run, but we would know it was negative. Okay, here things get a little bit harder, but not too much. Find the slope and y-intercept of the linear function. So we know this has to be linear. There's a rule here that would fit the format of, let me change the color, of y equals mx plus b. We don't know what m is. We don't know what b is yet. But we do know a lot of information. We know that the point 0,5 is on the line. We know 1, 3 is on the line. And all these are points that are on the line because they're in our table. They're in our function table here. And so there's this old formula, and it's y2 minus y1 over x2 minus x1. And that's really just a complicated way of saying rise over run. Let me explain that. And I hope you really understand this because this is kind of crucial to understanding the big picture. When you think about rise, you're thinking about the vertical difference between 2 points. Like over here, we counted, let me go back one more. We counted the vertical difference between these 2 points, then we counted the horizontal difference. Well, all this does, when you take 2 points and you subtract the y's, you're finding the vertical difference. When you subtract 2 x's, you're finding the horizontal distance. So the first step, and if you want to write these down in steps, go for it. The first step is just to pick 2 points. It doesn't matter what 2 points you pick. I'm going to pick 1, 3, and I'm going to pick 2, 1. And you could have picked any 2 you wanted. And the trick there is to just subtract the y's. That's what this means up here. Subtract the y's. So I know that in every point that I get, x is listed first, and then y is listed second. So I know these are my y's and these are my x's, right? So I'm going to subtract the y's. 3 minus 1 is 2, and 1 minus 2 is negative 1. But now I have to remember to put them in the right place in the fraction. So the y difference goes in the numerator. That's this one. And the difference between the x values goes in the denominator. It's this one. So our slope is -2. Okay, that was actually not too difficult. And that's all there is to it. The only reason this says y2 and y1 and x2 and x1 instead of just y's and x's is because there's 2 points. So don't let that confuse you. Don't let the fact there's a 2 here and a 1 here confuse you. That's just to differentiate or tell the difference between which y values you're talking about and which x values you're talking about. Okay, so we now know the slope, but the y-intercept here is actually really easy if you see it. Anytime you have an input of an x at 0 and then an output of a number, that's your y or your y-intercept. Because that means, if you're going to graph that point of 0, 5, you wouldn't go left or right because the x value is 0, but you would go up 5. 1, 2, 3, 4, 5, and you make a point. So that's where this line is going to run through. So I know that 0, 5 has to be my y-intercept. Okay? So let's break that down real quick. The first thing I did was I picked 2 points, and then I subtracted the y's and the x's to find the slope. The only difference between that and what we did before was before we just counted it because it was on a graph. The y-intercept here, instead of just looking to see where the line went through the y-axis, I just looked at the point. And I know that if my x is 0, the next number is going to be on the y-axis. Okay? So this right here would be my answer. This is the slope, and this was the y-intercept. Okay, one more example. But before we get to that, here's your number clue. It's greater than 50. Okay, in this problem, the relationship between the time driving and a car's distance is linear. All that means is the car is not speeding up or slowing down. Okay? After driving 3 hours, the car traveled 75 miles. So that must mean we have the 0.375. After driving 4 hours, the car traveled 100 miles. So we got the 0.4100. Because if I did an x and a y table here, where x was my time in hours and y was my distance in miles, I would have a 375 and a 4100. Now, the only difference between this and example 2 is it's in a word problem. So now we do the same thing. We subtract the y's. Remember, these are my x's, these are my y's. And it doesn't matter which point you subtract from which point, as long as you're consistent. So because I see that the values in this point's larger, I'm going to write those on the top just to make my life a little easier. And I'll put this number in the bottom. It doesn't matter, though, because if I had switched it around, both of them would have been negative and the fraction would have come out. So I know 100 minus 75 is 25, and 4 minus 3 is 1. So I have to remember that the slope is rise over run, or the change in y over the change in x. So I'm going to put the change in y in the numerator and the change in x in the denominator. So it looks like the slope here, m, is 25. Now, in this particular case, it'd be very difficult to find the y-intercept because I didn't tell you how far the car traveled at 0 hours. I'm actually kind of joking when I say that. Here we have to really think hard. Okay, if we know the car traveled 75 miles in 3 hours and 100 miles in 4 hours, at 0 hours it traveled 0 miles because it hadn't been traveling. Therefore, the y-intercept has to be 0, 0. In other words, it's this graph is going to start right here, right in the middle, and the slope is 25, which happens to be its speed or its rate of travel. And that's what the next video and our discussion is going to cover. It's going to be covering what do slope and y-intercepts mean in the real world. Okay? So really just 2 things. Remember what slope is, remember what y-intercept is, and find those. Good luck, guys.